Okay, so we're going to start with our definitions here of angle of elevation and angle of depression. These are going to show up in a couple word problems that we're going to need in a few minutes. So angle of elevation is the angle that is formed between a horizontal, looking straight across, and a line of sight looking up. So this will be, we'll call them Jack and Jill. Jack is looking up at Jill. Okay. That's his angle of elevation, meaning he looks directly at his post and up at her. Angle of depression is if you're looking down at something. So that angle is formed again between a horizontal, she looks directly out, and her line of sight looking down at him. Now, because the angles both contain a horizontal, in this picture we have parallel lines, and therefore angle of depression and angle of elevation are related how? This should be a familiar picture from geometry. They are equal to one another. Does anybody remember what kind of angles those are called? Has to do with interior, that's part of it. Close. Alternate interior angles is what they're called, and they are equal to one another. This picture is two parallel lines cut by a transversal. Does that sound familiar? Talked about that probably a lot in geometry. Okay. All right, so the moral of the story is we want to know they're equal because if we can't solve for the angle of depression, we could instead solve for an angle of elevation. Maybe if one is an inner triangle, the other one would be, and vice versa. So we're going to use that fact potentially in our next couple problems here. All right, so word problem. Of course, you don't have to write down everything, maybe just some of the important key pieces here. It says, from an observation deck 425 feet high on the top of a lighthouse, the angle of depression to a ship at sea is 4.2 degrees. How many miles is the ship from a point at sea level to a point directly below the observation deck? All right, so when in doubt, if you guys are doing any of these word problems on your homework or quizzes or tests, the good news is everything's going to make the same shape. The only shape we've learned about so far is a right triangle. So when in doubt, what you're drawing should form a right triangle. Okay, so we have a lighthouse. Here's my lighthouse. And there's, I don't know, top of it, something like that. Okay. And it looks like a candle. And then there's a ship at sea. There's my ship. You can see why I'm not an art teacher. And there's my water. Okay. At the top of the lighthouse, so observation deck, maybe like here, somebody is looking down at that boat and forming an angle of depression. Okay. Now, common mistake is that the angle of depression will be labeled inside the triangle that's pictured here. And you need to remember that angle of depression is formed by a horizontal. So imagine you're the person at the top of that lighthouse looking out straight across and looking down. That's our 4.2 degrees. We're also going to assume that anything sticking out of the ground forms a right angle with the ground. Okay? So there's a right angle. Now, if the angle of depression is 4.2 degrees, what else is 4.2 degrees? Angle of elevation, which is, imagine you're in the boat looking up. That's that guy down there. You can see those alternate interior angles. I also know that the observation deck is 425 feet high. Our job is to figure out how many miles the ship is out. Okay, so do you see our right triangle formed here? You need at least an angle and two sides labeled because then we're going to use our SOHCAHTOA ratios. From that 4.2 degrees, that's going to be our theta. How is 425 related? Opposite, adjacent, or hypotenuse? Opposite. And my x that I need to solve for is adjacent. And I'm not even going to label the other side because I don't know it and I'm not solving for it. So it's irrelevant for this problem. If you have opposite and adjacent, which basic trig function do we have? Sine, cosine, or tangent? It's tangent. So that tells me how to set it up. Tangent of an angle, 4.2 degrees in this case, we know our angle, is equal to opposite over adjacent, 425 over x. And then we can solve for x. How do I solve for x? What do you do first? multiply by x, got to get it out of the denominator. And then in your calculator, you're going to do 425 divided by tangent 4.2. Before you do that in your calculator right now, hit mode. And make sure that degree is highlighted. If degree is not highlighted, scroll down to the word degree and hit enter over it to make it highlighted. We want to be in degree mode. We'll eventually be in radian mode also, but for right now, we're just going to stick with degrees. Okay? All right. So then you can go back to your home screen once you're in degree mode. 425 divided by tangent 4.2. I should probably make sure I'm in degree mode too. Oh, yep, I am. All right. And I get 5,787. I'll just round to the nearest foot. Okay. Does that answer the question that's being asked? What's the question? How many miles? And right now we have feet. So how many feet are in a mile? 5,280. So we could just divide 5,280. And we're going to get about 1.1 miles is how far the ship is. And you know Math Excel will be specific with what decimal place you want to round to. Okay? Any questions? Okay. Is my triangle drawn to scale? Is my triangle drawn to scale? Does this side, if this is 425, would this look like 5,787? No. We're just going to assume that all triangles we see are not drawn to scale. What you should think about is this angle. Does that make sense with what we're getting? That's a super tiny angle, right? So if I really were to draw this out, I would have a very, very skinny triangle that would slowly open up, which would give me a really long side on the bottom. Okay. All right. Let's try one more word problem. It says, from a point on the edge of two parallel rooftop sides, a point directly opposite is identified on the other rooftop at an angle of 60 degrees. From a second point 25 feet from the first point, a second siding to the opposite rooftop is made, and the angle is 45 degrees. How far apart are the two buildings? All right, so obviously we need to sketch some things out here. All right, so I have two buildings. They are parallel rooftop sides, and one is shorter than the other. One person on one building is looking up at the other building. Okay, so there's my buildings. All right, so it says from a point on the edge, we look up at the edge of the other rooftop, and the angle that is formed is 60 degrees. That is an angle of elevation. So imagine looking across, looking up, 60 degrees. We assume anything sticking out of the ground is going to make a right angle with a horizontal. Okay. Then a second siding is made 25 feet back. So they move 25 feet back and look up at that same point again. This time, it's at 45 degrees. Our job is to figure out how far apart are the buildings. Okay. Do I know anything else? I think that's all I know, right? Okay. So, we can't solve for x yet. I'm going to use this little guy y to help me. How are y and x related to 60 degrees? We're talking about our relationships between sides and angles. Opposite, adjacent, hypotenuse. How are y and x related to 60 degrees? It's going to be a tangent, right? Because y is opposite and x is adjacent. So tangent 60, I'm going to set that up. Opposite over adjacent. Okay, so that's the little triangle that we just looked at. Now, do you see the bigger triangle? How there's two triangles in this picture, two right triangles? Okay, so we're going to do the same thing for 45 degrees. Y is opposite 45 degrees, and this whole side, 25 and x, is the adjacent side. So again, I'm going to make a tangent function. Tangent 45 opposite y over the adjacent side is 25 plus x. What I've formed is a system of equations, two equations that have the same two variables. Now, tangent 60, tangent 45 are just numbers, so don't let those, freak you out here, okay? You could type those in your calculator and get a decimal at this point if you wanted to. We just have a linear system of equations that we have to solve. What makes both of them gross is you have a denominator. So what I'm going to do in both of these is multiply by the denominator. So I'm going to make it x tangent 60 equals y, and 25 plus x tangent 45 equals y. And in doing that, I got the y alone actually in both equations. So if they're both equal to y, what can I do with them now? Set them equal to each other. Since they're both equal to y, it's really just using substitution to solve. So I can say now that x tangent 60 is equal to, and I'm going to go ahead and distribute that tangent 45 through, 25 tangent 45 plus x tangent 45. Okay, so let's use our calculators now to get some numbers in here. Type in tangent 60, 25 tangent 45, tangent 45. We can get decimals for all three of those. If I type in tangent 60, I get about, I'll do two decimal places. 1.73 is going to be with my x. 25 tangent 45 just gives me 25 because tangent of 45 is going to be 1 eventually. All right, and tangent 45 again, you're going to see is 1 with your x. So now how do I solve for x? Just a linear equation, right? Get the x's together, probably, because they're on either side of the equation. Move one of them. If I subtract 1x, I'm going to get 0.73x equals 25, and then divide by that 0.73. And you could always give it a few more decimal places if you need to. Approximately 34.2, and what am I labeling here? Feet is my unit of measurement. Okay, so that one's a little tricky. I thought it was definitely worth going through together before you saw it in a Math Excel problem. Drawing especially, getting that and setting up that system. Okay, any questions on that? Okay, so those are all the word problems we're going to do today. The last part of this lesson is going to be, let's call it a brief introduction to identities. We do a lot with identities in chapter 6. Pretty much the whole chapter is going to be about identities. For right now, what we do in this chapter are just some of what we call the fundamental identities, the basic ones that we're going to use throughout with our right triangles. You need to get these in your notes. So there are 3 sets here, and then there's one more set on the next page. I'll give you a few minutes to write them down, and then we're just going to kind of practice with these on how to use them. The first group of 6 on the top left there, the reciprocal identities, we kind of talked about those already when we were doing our right triangle calculations earlier last week, when we said cosecant is just the reciprocal of sine, and secant is just the reciprocal of cosine. So those identities are just a fancy way of saying if you want one function, you can take another one and flip it, which is what we were already kind of doing. The quotient identities at the bottom are for tangent and cotangent. Tangent is sine over cosine, and cotangent is cosine over sine. And then finally, the Pythagorean identities. Pythagorean identities come from the Pythagorean theorem when we start looking at some different right triangles. The first one, if you recognize any of them, sine squared plus cosine squared equals 1. It's probably the one you recognize. And then we also have relationships with tangent and secant and cotangent and cosecant. When you see it squared like that, that means sine of our angle parentheses squared. It's the whole sine of the angle squared, not just the function itself. That doesn't make sense. We usually don't write it like this, though, because it's a little tedious with the parentheses. And if I didn't put the parentheses there, it would look like the angle squared. So that's why they put the squared sign where you see it. Okay? All right, so I'll give you a couple minutes to write those three down, and then we'll get the last set on the next page, and then we'll practice with them. All right, and then the last set you need to write down are the cofunction identities. Now, these ones are written in terms of degrees. You can also write these in terms of angles with radians, and you would just replace the 90 degrees with a pi over 2 if you saw it with radians. So if you Google like cofunction identities, you might see either form of these. So the cofunction identities are maybe a pattern you noticed when we were doing the 30, 60, 90 triangles last week. You should have seen in those that we were getting a lot of the same answers for sine and cosine. They were just flipped. And tangent and cotangent were just flipped. And secant and cosecant were just flipped when we changed the angle from 30 to 60. That's actually this property. It says that the sine of any angle, like sine of 30 degrees, for example, is equal to the cosine of 90 minus that angle, which is a fancy way of saying the complement of that angle. So if I have 30 degrees, the complement of that is 60. And they come in pairs, sine and cosine, tangent and cotangent, secant and cosecant. And I think they get their name cofunctions because they have the word co in front of them. Sine, cosine, that's a pair. Tangent, cotangent, that's a pair. Secant, cosecant, that's a pair. That's how you know which ones go together for the cofunction identities, because they have the same name. One of them just has a co in front of it. Okay. So if they're cofunctions and they're complementary angles, they are equal. So when we use these are typically some of the easier identities, and there's an example at the bottom here. It says, given that cosecant of 21 degrees is approximately 2.7904, find the secant of 69 degrees. Now what they want you to recognize is, first of all, 21 and 69 are complements of each other. They add to 90. And we also have cofunctions, secant and cosecant. So according to this identity set, if they're cofunctions and complementary angles, they're equal. So if one of them is 2.7904, the other one is 2.7904. That is your answer. They're just asking you here to recognize that you see that they are equal, that those would be either side of one of these functions. Okay. And you can see it's kind of repetitive. The three on the left column there are pretty much the same three on the right column. They just put the 90 minus on the other side. All right, good? Okay, so now I want you to write down this problem. It says, let theta be an acute angle with cosine equal to 1 over rad 3. We're going to find the following using identities. Okay, so we have an angle, it's an acute angle, its cosine is 1 over rad 3. We're going to find the following using fundamental identities. Now, the easier way to do this problem, I will preface this, is to do what we were doing earlier in the chapter. To draw a right triangle, put a theta there, label your adjacent and hypotenuse because you have a cosine, and then find the third side. Once you have all three sides of a right triangle, you can find any trig function you're missing. This is a good way to check this problem, but it's asking you to use the identities. So if this were a quiz or a test, you'd have to show how you are using these properties to answer this question, and then of course check it with the right triangle if you want to. Okay, so let's start with sine is the first thing I have to find. I have cosine, I want sine. So my job is to figure out an identity, one of our functions, that relates sine to cosine, where only sine and cosine are located in that function. So like the quotient identity, for example, tangent equals sine over cosine, I wouldn't want to use that one because I don't know tangent. There would be two unknowns in that equation. I also don't want to ever use cofunction identities unless you see something like this. It will be super obvious that you're going to use a cofunction identity because there's going to be a 90 minus in it. Okay. So what other identity relates sine to cosine where those are the only two functions in the equation? Right, the Pythagorean identity that says sine squared plus cosine squared equals 1. Okay, well, I already know what cosine is. And all I have to do is square it. Well, if I square 1 over rad 3, squaring a fraction, I just square the numerator, square the denominator. Square the numerator, it's 1. Square the denominator, it's 3. Okay. How do I solve for sine now? This is just a basic equation. What do you do? Gotta get it alone, right? Come on, guys. This is supposed to be the easy part. Subtract a third. 1 minus 1/3 gives me 2/3. And I have my sine alone, but it's squared. So how do I get rid of a squared? Square root. So I'm going to end up with sine equals, if I square root the numerator, it's square root 2. Square root the denominator, it's square root 3. That's my answer. Only thing wrong with this answer is what? It's not rationalized. So I'm going to multiply by the denominator over itself. My final answer is going to be square root 6 over 3. Because square root 3 times square root 3 is square root 9, which simplifies to 3, or you can remember a radical times itself gives you the number underneath. Okay. So now I have cosine and sine. I want cosecant next. You can use either sine or cosine or both if you want to. Can you give me a function that relates sine and cosecant or cosine and cosecant? One of our identities. Yeah, the reciprocal. That's actually the easiest one to use, right? Because it says all I have to do is take a function and flip it. Sine and cosecant are reciprocals of one another. Now, this is an opportunity where I can work smarter, not harder, right? I can take this answer and flip it, but then I'd have a radical in the denominator. I'd have to rationalize. I'd probably have to reduce. I can take this answer and flip it. I still have to rationalize, but I probably won't have to reduce because my numbers are smaller. So I'm going to take that one and flip it. The rad 2 over rad 3. It becomes rad 3 over rad 2. And then if I multiply by the denominator, square root 2 times square root 2, I get rad 6 over 2. Okay? And if I'm labeling things, that's reciprocal. And up here we use Pythagorean. Just have those for our notes for later if we need them. Okay. So now I have cosine, sine, cosecant, and I want tangent. How can I get tangent? Using any of those, or any combination of those. We haven't used that. Why not? Quotient identity says tangent is sine over cosine. Okay. And I'm again going to use my basic, the ones with the radicals. So my cosine is 1 over rad 3. Right, like that. And my sine was rad 2 over rad 3. I'm using the unrationalized version of it because both of them have a rad 3 in the bottom. So what ends up happening is this guy reduces by 1 over rad 3. Those rad 3s, because they're both in their respective denominators, can just cancel. And I end up with rad 2. Another way to see that they can cancel, instead of dividing by a fraction, you can multiply by the reciprocal. You can see that they would cancel that way. Okay? Last but not least, secant 90 minus theta. If you see a 90 minus, you know it's going to be a cofunction identity. Which function in the cofunction identities is friends with secant? Cosecant. According to the identities, 90 minus 1 is equal to the other. So cosecant of theta, actually we already have that. My answer is rad 6 over 2. Okay, now this one was a little bit more difficult only because it had radicals. Our last problem today is yours. It's very similar to this, but there are no radicals, so it should be a little bit easier. And if you want to check your answers, you can draw a triangle, label your sides, and calculate the functions from the triangle if you want. Okay, so I'll give you guys a few minutes. find a friend, a group, whoever you want to work with, try them, we'll put them up, and that'll be the end of our lesson for today. All right. So what did you get for cosine? 3/5 is correct. Again, Pythagorean identity, probably to get that right. Sine squared plus cosine squared equals 1. Secant is the reciprocal of cosine. So if you take cosine and flip it, you get 5/3. Tangent, I'd probably again do sine over cosine. 4/5 over 3/5, which will just give you, when those 5s cancel, 4/3. And then cotangent is a cofunction with what other function? Tangent, which is 4/3. Checking it with the triangle, if I have my angle theta, sine is opposite over hypotenuse. If you do the Pythagorean theorem, you'll get 3 for the adjacent side, and then you can see how you would get cosine adjacent over hypotenuse, 3/5. Secant will be the opposite, 5/3. Tangent, opposite over adjacent, 4/3. So it's a nice way to check it at the end, okay? What questions do we have on this? All right, that's the end of 5-2. 5-2 is due on Friday, yep. So this week, because of the snow day, we don't have to change any deadlines because they were already like pretty lengthy time periods anyway. All we're going to do is just get rid of the Math Excel workday on Friday. So calendar is pretty much going to stay the same after this week. So we're going to do 5-3 tomorrow and Friday, just no Math Excel workday, and then Monday we'll be right back on track is the plan. And I already adjusted that in the WAG in Polaris for you. Okay? All right, so you guys have about 15 minutes if you want to work on anything. Don't forget to give me your circuit training if you have it.